Hello everybody, and welcome back to another WingSmith video. This one is going to be covering the battery charger that comes in your kit. So this is the ISDT AC608 AC battery charger. I've got it unplugged right now just so we can talk about it, but it's got some features and some plugs that you'll want to know, especially if you're just getting started with FPV. So the first thing to note is the plugs. You've got an AC power cord that plugs in the side here. And so one end just plugs in. It's actually omnidirectional, so you can just plug it in on either side. And then our versions come with a North American plug, so you can just take that and plug it into the wall outlet. And when you do, you'll power on your screen. You'll see a readout here that shows the voltage that's detected in the cells. And then this charger supports between 2S to 6S batteries. There's a balance port here on the left side that has pins on it. And then you've got your XT60 port here, which matches up with 6S batteries. And you might be wondering how we plug these in. These are XT30 batteries that come with things like the Hummingbird, and we'll get into that in just a moment. So the only other thing of note on the side is this rotating wheel. It allows you to choose your menu, and so you can scroll through and see different information about the battery you're charging. Right now I don't have anything plugged in, so everything reads 0, 19 volts, max, etc., and then a temperature range and some wattage. So not too much to show you just yet. Before I continue on here, I'm just going to unplug it because this actually has two different ways of using it. One is plugging it in through that wall adapter, but it actually slides apart. So if you see there's a seam here, I can just press. I can just press on the side and it comes apart. You've got another XT60 connector up here, and this is basically the power converter that allows the wall power to be converted for the charger. But if you have a very large, say 10,000 milliamp hour battery or a power bank, you can plug this in. It also works with your car. So if you have an adapter that takes, say, power from your car and puts it through this guy, you can also charge your batteries that way. So because I'm using it inside, I'm just gonna plug these rails back through, slide it together, plug it back in, and now I'll show you how to use it with your batteries. So the first thing I'm gonna show you is a simple example of a 6S battery. There's two plugs on this guy. There's your power lead and then your balance lead. You're going to want to plug both of these in so that your charger not only charges your battery, but also does something called parallel charging or balance charging. Balance charging is where all 6 cells within this battery, or 4 cells within a 4S battery, or 2 cells in a 2S battery, are charged at the same time. This protects your batteries. So I'll show you how this is plugged in. First thing we're going to do is take our balance lead, and you can see here that it's from 2 to 6S. So we plug in from the left side to the right. Now this is a 6S battery, so it is going to take up the whole balance lead. But on a 4S, we'll see that that's a little different. And now that we've plugged in, you can see a readout on our screen here. I'll just lift it up so you can see all of our cells within our battery are reading at 3.72 or 3.73 volts. The storage voltage for a battery is about 3.8 volts. That's kind of like the nominal charge for the cell. That's where you're going to want to keep it if you're storing your battery. And so this is a relatively healthy battery that's been sitting for a little while. It could use a bit of a charge. I'm going to rotate the wheel on the right and just show you that if we go down, we can see some more information about our battery. 22.4 volts, and that's about it. Okay, so I'm now going to plug in the charge lead. Excellent. And if I click the wheel, we're going to see a menu for charging. So I'm going to click the wheel. We're now in our task settings. This is going to be what we're setting to do. We can choose different tasks to perform. Charge is a very common one. But if I click the wheel, you can see we can discharge, storage, DC power, and destroy. I would never recommend you click the destroy option. If you do want to take your voltage down to a safe level for putting in a bag and storing it, you can always choose your storage option. That will take it down to that 3.8 volts. And then discharge is to basically remove charge, but it won't necessarily stop. If you're using any function, I would recommend that you either use charge to bring it up to whatever you set it to, or storage to bring it down to a safe storage voltage. I would effectively never use destroy, and while discharge certainly has its place, using the storage is a safer way to give it an automatic stop point that's going to preserve the life of your battery. So I'm just going to show you what it's like when we charge. I'm going to click charge. We're choosing our LiPo. You can choose several different kinds in your chemistry. Lithium ion, if it's a lithium ion, it's a lead battery, but the most common types are going to be a LiPo, which is this type of battery, or you might have a lithium high voltage. This is going to be something that you can see on the battery. You can see here it's got a little HV symbol, and you should also be able to see that it's got 4 cells. Let me see if I can just get this to focus. We have 4 cells, but we have 15.2 volts. What that means is that a normal cell has 4.2 or 3.8 nominal. You can take it up to 4.2. So on a normal LiPo battery, you're going to go up to 4.2. On a high voltage battery, you can go up to 4.35. And so there's just a difference in the capacity of the battery very slightly. The most common is LiPo, and if you charge a LiPo high voltage set as a LiPo, you're going to be fine. If you charge a LiPo as a LiPo high voltage, you actually could overcharge your battery. So just be careful that if in doubt, always charge to LiPo, and that there are some batteries out there that can go to a higher voltage per cell. Again, that's 4.2 up to 4.35 for lithium high voltage. But in our case, this is a 6S battery that's just a lithium polymer. Okay, so I'm going to click the button again. We can see that our balance lead is reading correctly, that we have a 6S battery. You can actually choose the current that you want to apply, and by default, this is going to be set to 1A. I would recommend that when you're starting, you always charge at 1A. This is basically a rate that is applied to the battery that is going to be safe, and 1A is the safest that you'll always be. You'll basically, by default, always have batteries that can charge at 1A, but if you have larger batteries, you can accommodate higher basically amperage into your battery, but I would recommend to begin with, don't worry about it, just choose 1A and you'll be good to go. And now we've been through the basic settings, so we can hit start, and this is what the charging screen looks like. This will be red until the charging meter in the top right is complete, at which point it'll change to, I believe, blue. And so this is everything you can see about your battery. This is the cells, and you can see that slowly over time we'll climb from 3.73 to 3.74 up to the 4.2 that we're expecting to end with because it's a LiPo battery. I'll turn down here and you can see the resistance levels. These are just relative. So you're going to want these not to be exactly the same, but like relatively close. So you can see that I've got a 2.5 and a 4.1 and a 3. There's going to be some variance as the charging occurs over which cells have which resistance. But if one reads 0, that's going to be a big indication that something's wrong with your battery. If I keep going, you can see the same like details that we ran into before. And now we'll go back. This all looks good. If you ever want to pause your battery because you need to step away, you should always supervise your battery charging. So if you need to step away, you can click the wheel again. You can say, I want to change the current, I want to stop, or I just want to go back. As this is a demonstration, I'm just going to click stop. And now you can unplug your battery safely. Okay, so what if you have a 4S battery? So this has got a different style of plug. This is called an XT30 plug, and it doesn't fit in the XT60 connection. So WingSmith drones come with just a simple converter. This may be a solid, this may be a flexible connector, but it basically just converts an XT60 to an XT30. Yes, it works safely. You just plug it in, and then you can plug in your XT30, and then you take your balance lead, but now it doesn't fill all 6 pins. You just plug it as far as you can to the left, just like that. And again, you can see our battery information. We've got 4 cells here at 3.79, so we're very close to our storage voltage. You can see there's 4 cells. This is a 4S battery. That's exactly what we'd expect. So I'll click to go to the next one. Because this is a lithium high voltage battery, I can actually change the chemistry to lithium high voltage. And you'll see that the condition has automatically changed to 4.35. And again, we can leave our current at 1A. That's a safe charging rate. We're going to give a charging task, and we're just going to hit start. Okay, so just like the 6S battery, we're now charging. I can scroll through. We'll have some resistances show up here in a moment, and as you can see, it's 11.8 down to 10.3, and some generic information about the battery. So in terms of using the charger, that is the basics. Now I'm going to pause this and show you some other say challenges about batteries and battery safety, because you're not going to want to charge damaged batteries. The fastest and worst thing that you can do with FPV is effectively turn your batteries into fire hazards. The most common way to have a battery go bad on you is during the charging process. Batteries do not tend to spontaneously combust, and if you leave them sitting, they will normally just degrade over time. The best way to preserve them is bring them back to the storage voltage, but while you're charging them, there's 2 things you want to keep in mind. Number 1, you don't ever want to charge a battery that's physically damaged, and number 2, you want to supervise the charging, because you can interrupt if something is going poorly. You'll see things like a swelling battery, or you'll be able to feel that it's heating up. And if you intervene, you can prevent that battery from becoming a fire hazard. You'll want to dispose of it safely following that, but you certainly want to be there to keep an eye on things if something's going south on you. So I'll show you a couple of examples here on batteries that may appear otherwise normal, but have some obvious conditions when you look at them more closely. So the first one is going to be this lithium high voltage 750 milliamp hour battery. On this side, it seems totally fine. It seems great. But if I flip it over, you can see that I've punctured the cell on this battery. There must have been a screw or a piece of wood or something that this battery has been punctured by. And now that this cell has been, the aluminum around this cell has been damaged, I'm not going to charge this battery. It's dangerous to do so because there may be a short within the cell, and if I do, I can cause a fire hazard because that electricity is going to convert to heat, and that's what leads to fires. So this is an unsafe battery to charge. It's only about $10, $15 to get a replacement battery. So I wouldn't consider this a major loss. It's kind of just one of those consumables of FPV drones, and they are pretty well protected on top of the drone, especially these small ones because they have such low mass. But don't feel like you need to recover a battery like this. You can always get another one. This can be disposed of in a safe manner, and so we're just going to put this aside, and it's going to be a good example of a battery you don't want to charge. Next, we've got this battery that's also taken a small amount of physical damage, but here it's unclear if our cells have been punctured. We can see that the plastic has been pulled back on this end, and there is some foil within the battery that we can see, but it doesn't seem puffy, it doesn't seem hot to the touch, so we're going to need to do a little bit more exploring or investigation to see if this is a battery we can use. So I'm going to unplug this converter, and now plug this battery in to see if it's safe. First thing I'm going to do is plug my balance lead in to see if we can detect all of our cells, and right away you can see that while this is a 6S battery, we only have 5 cells available to us, or 5 cells that are reading a voltage. There should be 6, and so our battery is now damaged. If I click beyond this screen And I'll plug this in just to demonstrate. You can see that we can still access the charging menu. Now I'm going to say set this to LiPo, and we're going to imagine that I don't know that this has been damaged. Maybe I wasn't paying attention, or maybe I'm brand new to FPV and I haven't totally understood all the nuance between how many cells the battery has and what I should be seeing on my charger. We're going to imagine I haven't watched this video, and so I'm going to say, yep, I want to charge. It's a LiPo battery. I want to take it to the Classic 4.2. It's a 5S battery. Well, that's interesting. I'm going to pretend that I even want to charge this battery so bad, I'm going to set it to a 6S, and then it's got a safe current, so I'm going to hit start. All right, and you're going to see immediately that the battery charger automatically detects that there's something wrong with this battery. So I'm going to click the button on the side. We're going to return. You can see that it's not charging anymore. And so you've got lots of different ways of seeing that the battery isn't healthy. If you get that warning, you can always come back to this screen and see if you're reading voltages that don't make sense. And so hopefully this gives you an idea of how to approach battery charging. When you've got good batteries, it'll be very obvious that you can use them because you'll be able to step through the charging screen, you'll see the number of cells that you're expecting, and everything should be relatively straightforward. You'll always want to be with the charger while you're charging your batteries, and when it completes, it will automatically stop charging. When you have a damaged battery, especially if there's punctures in these cells, then don't be afraid to just dispose of the battery in a safe manner. There's really not any reason to put your own safety or your house in danger because of a $10, $15 battery. And the charger itself does have warnings and alarms for when you can't tell if the battery is damaged through that quick visual inspection. So I hope you've learned something today. This is a little bit of battery safety for the WingSmith drone system. And if you have any questions, reach out anytime. Cheers.